Lesson 3-3, Solving Multi-Step Equations. And in this lesson, you learn to solve equations involving more than one operation and to solve problems by working backward. Okay, let's take a look at this real life example. In June 3, 1993, Japan's Crown Prince Naruhito with former diplomat Masako Owada, okay, and it took 2.5 hours to put her wedding kimono, a 12-layer silk garment, okay, that weighed about 30 pounds. That's pretty heavy. Okay. The prince wore a kimono, a bright orange, the sunrise color, that can be only worn by the heir to the throne. After the wedding, the crown prince changed into a tuxedo and the princess into a bridal gown to formally announce their marriage to the emperor and to the empress. To change the bridal gown, Princess Masako and her attendants had to remove the wedding kimono, a process that was similar to putting on the garment, only in reverse order. Okay, so you will solve certain kinds of problems by working in reverse order or working backward. Work backward is one of many problem-solving strategies that you can use to solve problems. And here are other strategies, just like uh, Miss Owada wore. Okay, 12 layers. Before you can take off those 12 layers, you need to undo the 12 layers by taking off one layer at a time, starting from the last layer going down to the first. Okay, that's working backward. Some other problem solving strategies aside from working backward, drawing a diagram is one of them. Okay, we have creating a table of a chart. We've done this a few times. Making a model, definitely. Guess and check a lot of times. Okay, check for hidden assumptions. Using a graph, solve simpler or similar problem. Eliminating possibilities. Okay, when we did the matrix logic. Looking for a pattern, acting it out. List possibilities and identifying subcodes. These are all problem solving strategies that you can use to solve a word problem. In this lesson, we are going to concentrate on working backward. Okay, and let's take a look at example number 1, see how that works. Due to melting, an ice sculpture loses 1/2 of its weight every hour. After 8 hours, it weighs about 5/16 of a pound. How much did it weigh in the beginning? Okay, so that's our example, how much it weighed in the beginning. So we make a table to show weight as a function of time. So this is our weight as a function of time, meaning our weight is dependent on time. Working backward to find the original weight. Okay, so it says there after 8 hours it weighs 5/16 pounds. So we start there after 8 hours. That is the weight of the ice sculpture. Okay, and then we slowly go back, multiply the current weight. Okay, recall that the sculpture loses 1/2 of its weight every hour. Therefore, multiply the current weight of the sculpture by 2 to find its weight an hour before. So instead of dividing by 2, because that's what happened there, okay, it loses 1/2 of its weight. We do the opposite. We do the reverse of division. Instead of dividing it by 2, we multiply it by 2. So in hour 7, multiplying it by 2, you have 5/8 of a pound. Hour 6, multiply 5/8 by 2, we end up with 5/4 of a pound. Hour 5, multiplied 5/4 by 2, 5/2, and so on and so forth, continuing the multiplication process, okay, until you have hour 1. The weight now is 40 pounds, okay, and in 0 hour, the weight is 80 pounds, okay. So the total weight, original weight of the sculpture was 80 pounds by using this table and working backwards. Okay, and to solve similar equations like this, for that here, okay, Mrs. Guzman's washing machine needs fixed. Okay, and in trying to solve this, but before we do that, I guess I forgot something here. At the very bottom it says to solve similar equations. Well, not really, it should be here. Okay, so to solve similar equations with more than one operation, okay, we call this what we call a multi-step equation. you can do operations, or you can undo the operations by working backwards. So if we have a multi-step operation, we could follow the same procedure by working backwards. Let's take a look at this example. Mrs. Guzman's washing machine needs fixed. Since her machine is pretty old, she doesn't want to spend more than $100 for repair. Our service call will cost $35, and the labor will be an additional $20 per hour. What is the maximum number of hours that a repair person can work and keep the total cost at $100? Okay, again, let's see what we know. Let's read the problem. Okay, and let's define the variable. And in this case, we let H represent the maximum number of hours the repair can take. So we represented H, the number of hours the repair can take. Okay, and then we simply write an equation using the information that we gathered. So $35, okay, is for the service call. Okay, we're going to add $20 per hour for 8 hours. So that means after the service call, it's going to be $20 per hour, and we don't know the number of hours, and that's 20H equals 100. Okay, because it says here her machine is pretty old. She doesn't want to spend more than 100, so the amount should be around should be equal to 100. And let's solve this problem backward. Okay, we have 35 plus 20H equals 100. Okay, undo the addition first, use subtraction. Why do we do that? If you recall, in our order of operations, okay, before we learned PEMDAS, we learned MDAS. Okay, so in our order of operations, we did multiplication and division first before we did subtraction and subtraction or addition. So multiplication and division before addition or subtraction when we are doing the order of operations. But when we are solving, okay, for the variable H, we go opposite our order of operations. Okay, so here, if you notice, to be able to solve this problem, you have to multiply 20H first, and then you add 35, and then it equates to 100. So when you're trying to solve an order of operations, we go do the opposite. Okay, Saddam, you undo subtraction and addition first before you do division and or multiplication. Let's take a look at this problem and see how this works. You have 35 plus 20H equals 100. We need to undo addition first, okay? Because in 35 plus 20H, we did multiplication first, and then we added 35. So to solve for H, we need to undo 35 because we're working backward now, and then we need to undo 20 later on. So we subtract 35 to both sides, okay? Use the subtraction property of equality, you end up with 20H equals 65. Now that we've undone, or undid 35, we need to undo 20H. And if you notice, 20H is a multiplication operation. Just like in the previous example, to undo multiplication, we need to divide both sides by 20. Now I have 20H over 20 equals 65 over 20, and the value of H would be 13 over 4, or 3 and 1/4. The repair person has up to 3 1/4 hours to fix the washing machine, okay, so that they will not spend over 100. And check to see if your answer makes sense. If you get 3 1/4 hours, multiply that by $20. It's equal to $65 dollars. And if we simply add 65 plus 35, you end up with 100. Our answer checks out, okay, and it makes sense. And that's how you solve a multi-step equation, by working backward. Okay, let's take a look at example number 3. Okay, in example number 3, you have seen a multi-step equation in which the first or leading coefficient is an integer. You can use the same steps if the leading coefficient is a fraction. Okay, and this is example 3. Solve each equation. Y plus 5, y over 5 plus 9 equals 6. So first things first, we copy down the problem. Y over 5 plus 9 equals 6. The leading coefficient is 1/5. Remember the definition of a coefficient. The coefficient is the number before the variable. Why is it 1/5? Because y over 5 is the same as 1/5 times y. And that's why the coefficient of y is 1/5. Okay? So knowing that, okay, the coefficient being 1/5, we want to undo addition first, okay? Because in our order of operations, again, okay, we need to divide and then we need to add, okay? So if we want to work backwards, then that means we need to undo addition before we undo the division. So we do this by subtracting both sides of the equation by 9, okay? Again, why do we subtract by 9? Because we are working backwards and we want to undo positive 9, okay? So doing that, we're left with y over 5 equals -3. Again, we know for a fact that y over 5 is a division problem, and in order to undo division, we need to multiply, okay, to undo 5. So we multiply both sides by 5, end up with y equals -15. Checking our answer, we simply substitute the value of -15 to y on in our original equation. We now have y plus 5 plus 9, y over 5 plus 9 equals 6. Substituting the value -15 plus 5 plus 9, is it equal to 6? And indeed it is. Okay, so you have now, we've checked our equation, therefore the solution is -15. Okay, let's take a look at the next example. In the next example, you have d over 2 all over 3 equals 7. Okay, remember that when you have d over 2 over 3, that is a division problem. That means if it's a division problem, you need to undo, okay, the division by multiplication. Okay, so this take a look at this example, because you might get confused and say that we need to add 2 first. No, you don't. Why not? Because d over 2 is all over 3. Minus 2 is not separate from d over 3. Okay, so we need to undo 3 first before we undo the -2. We undo division in this case, because that is a fraction. And undoing division, first copy the problem down, okay, and then in order to undo that division, we multiply both sides by 3. And if we multiply both sides by 3, okay, if you notice that 3, okay, goes away or is equal to 1, so you now have d minus 2 equals 21. And then it's easy enough, that's a one-step problem now, one-step equation. So we add 2 to both sides, okay, and you end up with d equals 23. Checking if our answer makes sense, we simply substitute the value of 23 to our original equation and see if it is equal to 7, and we find out that it is. Therefore, the solution is 23. Okay. Next example, we'll deal with consecutive integers. Consecutive integers are integers in counting order, such as 3, 4, 5, beginning with an even integer, and counting by 2 will result in consecutive even integers. For example, -6, -4, -2, 0, and 2 are all consecutive even integers. Beginning with an odd integer and counting by 2 will result in consecutive odd integers. For example, -1, 1, 3, 5 are all consecutive odd integers. Okay? The study of numbers and relationships between them is called the number theory. Number theory involves the study of odd and even integers. Okay? So what is it saying here? It's saying that we have consecutive integers. Okay, we have the regular consecutive integers 3, 4, and 5, and consecutive odd and even integers. If you notice, when you talk about consecutive even or odd integers, okay, the difference is always 2. Okay, the difference is always 2. Okay, so if I am going to represent, for example, my first consecutive even integer, CEI, okay, if my first CEI is x, okay, If I represent that with x, my second CEI, or consecutive even integer, since the difference is 2, would be x plus 2. Okay? And my third consecutive even integers would be, okay, so in this case, it would be x plus 2 or x plus 4. Now, it does not matter if it's a consecutive even or consecutive odd integer, you will have the same let statement. So this is still the same, holds true for consecutive odd integer, second consecutive odd integer, and third consecutive odd integer. So the let statement for consecutive even and consecutive odd integers are the same. Okay, so the let statements are the same for both odd and even integers. Okay, let's see how this works. Find 3 consecutive odd integers whose sum is negative 15. First things first, we need to create a let statement. Okay, and our let statement will let n be the least odd integer, and what we talked about here, right here. Okay, so if n is our first consecutive odd integer or the least odd integer, the next odd integer in terms of n would be n plus 2, just like this one. Okay, the next greater odd integer, okay, and the third consecutive odd integer, or the greatest of the 3 odd integers, would be n plus 4. Okay, this says find 3 consecutive odd integers whose sum is negative 15. The word sum tells us that we are adding. So, knowing our let statement, okay, and representing all 3 integers, we can therefore say that n plus n plus 2 plus n plus 4 equals negative 15, where n represents the least odd integer, n plus 2 the greater, and n plus 4 the greatest odd integer. Okay, now that we set up our equation, it's easier to solve this. We simply combine like terms. We end up with 3n plus 6 equals 15, and then we are back to a two-step equation, undoing positive 6 by subtracting 6 to both sides. End up with 3n equals negative 21, and let's undo the multiplication of 3n by dividing both sides by 3. You end up with n equals negative 7. Now we've only answered part, okay, of the problem, because it's saying find 3 consecutive odd integers, and we found 1. So we simply substitute n to our let statement. So n plus 2 equals negative 7 plus 2. The next odd integer would be negative 5, and we get n plus 4. It's negative 7 plus 4, or n equals negative 3. So now the 3 consecutive odd integers are negative 7, negative 5, and negative 3. Alright, that's the end of our lesson. Okay, on Google Forms or My Big Campus, type a summary of what you've learned by responding to the objective of the lesson, objectives of the lesson, and type a question you may want to ask in class about this lesson. Thank you.